I am on page 73 in the textbook, and we're looking at example 4, which is talking about something called theoretical probability. Theoretical probability is based on the laws, the rules of probability, and you can use those rules to make predictions. So you can use the laws of probability to predict big events or events that would take a lot of outcomes to test. So here's the example. If you roll a number cube 50 times, 50 times, 50 times, how many times are you likely to roll the number 4? You cannot predict with certainty, but you can say how many 4s are most likely to occur. So first of all, let's get a very good picture of a number cube. Let's try that again. A number cube is a die. More than one are called dice. So one die is one number cube. When you say roll the dice, you're talking about 2 of them. If you're just rolling one, it's called a die, and I'll write that down for you. That's one of my grammar pet peeves. So this is one die that I have stretched out into its sides. So we have one side with a 1, one side with a 2, and I can't remember exactly how the dots look, but you get the idea. Okay, so we want to know the probability of rolling a 4. And let me move that over here. The probability of rolling a 4. So we write the ratio. On the bottom, we have the total outcomes, and that's going to be 6, because a cube, a die, has 6 faces. Of those 6 outcomes, how many of them are a 4? Well, there's only one. It's right here. You roll one die, you have one chance of getting a 4. Right? So the probability of rolling a 4 is 1 out of 6. Let's go ahead and convert that to a decimal. So on the calculator, I'm going to say all clear. 1 divided by 6 is, well, this is an approximation because I'm going to have to round. It is about 0.17 or 17%. But the question was not what is the probability of rolling a 4. The question is, if you roll the die 50 times, how many 4s would you be likely to roll? So we have to take the probability, 1/6, and do it 50 times. So 1 ABC 6 times 50 is 8 1/3. If you wanted to do that by hand, you would say 50 over 1. Gives you a 50 on the top and a 6 on the bottom. 6 goes into 58 times with 2 left, and that would simplify on down to 1/3. I would use my calculator on this one. So the probability of getting a 4 in 50 rolls is about 8 times. If you rolled it 50 times. pay attention to that word times, and that will help you know that you have to multiply there. This is an example of theoretical probability. In theory, this is what is likely to happen. Can I guarantee it's going to happen? No, I can't. But it's worth a try. Take a die that you might have lying around at home and just see. Roll it 50 times and keep track of how many times the 4 will come up and see if it compares. All right, here's example number 5. This is talking about experimental probability, which is a little bit different. Experimental probability is based on what happened in the past or in a previous experience, past performance, or past data. This type of probability is called experimental probability. And here's the story. The table shows the last 50 sales at Motor City. What is the best prediction for the number of Japanese cars sold out of the next 200 car sales? Well, here is the table. Let me duplicate that for folks who may not have the textbook in front of them. We have a table that is called type and number. And we have domestic, European, and Japanese, 24, 6, and 20. And we want to predict the number of Japanese cars sold out of the next 200 cars. So the first thing I want to do is look at the probability of a Japanese car out of this data. So set up your ratio. Once we get out of the examples, I won't be writing this down, but this will be all cars. And then this will always be this top thing. Whatever's in the parentheses will be the favorable outcome. So out of all cars, let's get a total here. I believe it said 50, but I still like to add it to be sure. So we have 24 plus 6 plus 20 is 50. So that's going to be on the bottom. And then the Japanese cars were 20 out of 50. You can go ahead and knock off a 0 to get 2/5. 2 divided by 5 on the calculator is 0.4 or 40%. Okay. So there is a 2 out of 5 chance that a Japanese car will be sold. Let's predict what that's going to be the next 200 times. So you can say 2/5 times 200. Let me just go ahead and show you that. 2/5 times 200 is going to be 400 over 5. And that's going to be 5 into 40 is 8, and then we have a 0. So I'm looking at 80. You could say 0.4 times 200 on your calculator, and you will get 80. Or you could do a percentage if you wanted to, where you have percent over 100, 40 over 100, 200 cars sold. That's going to be 40 times 200 is 8,000. Divided by 100 is 80. Just wanted you to know that any of these ways will work to get your answer, because all of those percentages are the same. 2/5, 0.4, 40%, they're all equal amounts. So any of them will work in your calculation. Okay, let's look at the core skill over in the margin. Regina is playing a game in which she draws marbles from a bag. The bag contains one white marble, two gray marbles, and three green marbles. So this is one bag. And how many total marbles are in there? 3, 4, 5, 6 total marbles. What is the probability that Regina will draw a gray marble on her first try? How many marbles are in the bag? 6 total. Of those 6, how many are gray? 2 gray. So that will be 2/3. Excuse me. How about 1/3? Which is approximately 0.33 or 33%. And this is not equals, this is approximately, because I rounded. So the probability is 1 in 3, or about 33%. And let me move that up here. All right, here's another question. Now find each of these probabilities using the bag of marbles shown below. So in the bag of marbles shown below, let me go ahead and tell you how many there are. There are white marbles, there are gray marbles, and there are blue marbles. This is one bag. And let me give you the proportions here. There are 4 white, 3 gray, and 2 blue. So there are 9 marbles total. And they want to know first the probability of a blue marble. So that's going to be how many blue? We have 2 out of 9 total. So 2 out of 9 is 2 divided by 9. That's 0.22 repeating, or 22%. The probability of white. Well, there are 9 marbles and 4 of them are white. So that's going to be 0.4 repeating, or about 44%. The next one is the probability of not blue. Well, there are 9 marbles in the bag, and 7 of them are not blue. 7/9 is 0.7 repeating, or about 77%. The probability of not white. That is going to be 5 out of 9. You might not even need the calculator on that one. You see the pattern that's happening. That's 5 repeating, or about 55%. And then finally, the probability of not gray. So out of 9 marbles, 6 of them are not gray, right? Yes. So that is approximately 6 out of 9 is 6 repeating, or about 67%. And I see a mistake. I need to go back to these that I've rounded. Boy, was I not paying attention. Let's look at this 0.77. If you write that out, as I should have, you would have 0.7777 forever. If you look at that, that's going to round to 0.78. Same with this one, 0.5555 forever. That's going to round to 0.56. And that was just a careless mistake on my part. I apologize to you for that. I caught it with 6/9 because that's the same as 2/3, and I have that one memorized. All right, so that was the core skill. And now we have think about math. There was a lot to do on this page, but I want to try to keep one video per page if I can. That's so much easier when I upload. All right, so here's Think About Math at the bottom of page 73, and here's number 1. If you flip a pair of coins 48 times, how many times are you most likely to get 2 heads? So we have a pair of coins. Gracious. Be careful here. You have to really understand what it's saying to you. So I'm going to make them be different colors just for reference. So here is a blue coin. Or we could say a penny and a dime or whatever. Here is an orange coin. And here's the back of it. So this is the front and back of a blue coin. So you have heads and tails on this one. Then the front and back of an orange coin, heads and tails on that one. So you flip 2 of them at the same time. You throw the 2 coins up into the air. What is the probability that this one will land heads up? Well, it could either be heads or tails, and only one of them is heads. The probability that this one would land heads up, well, again, you have 2 sides and only one of them is heads. So each of them has a 1/2 probability. So could we say that it's certain that they will land heads up? No, because we have the tails option in there. So here's what we're looking for. The probability that the blue coin will land heads up and the orange coin will land heads up. All right, now think about what I'm saying here. Orange will land heads up, blue will land heads up. The most important word here is and, because what does and mean in this kind of problem? It means to multiply. So you're going to have heads on this one times heads on this one. The probability is going to be 1/4, or 25. hundredths, or 25%. All right, number 2. A basketball player makes 15 free throws out of his last 45 attempts. How many free throws is he most likely to make out of his next 90 attempts? Well, if he makes 15 out of 45, we can use that to predict how many he will make out of 90. And I've broken my own cardinal rule of proportions. Made over attempts. 15 out of 45, that is not good for free throws. So let's use that factor to predict what he would do out of 90. So 15 times 90 is 1350. And 1350 divided by 45 is 30. Now, I will tell you that this is not how they wanted us to do this problem, I think. I'll have to look it up and see. But here's another way that you could do this problem. He made 15 out of 45. If you simplify that down, it'll work by 15, but I think most people would think of a 5. So you're going to have 3/9, which will go again by 3. That means that his free throw percentage is 1 out of 3, or 0.33, or 33% free throw shooter. And then you can take the 90. You could do 1/3 of 90. So that's 1/3 times 90, which is 90 over 3, or 30. You could also say 0.33 times 90 on your calculator. 90 times 0.33 is 29.7, which would round to 30%, or 30 free throws, excuse me. So any of those ways will work. We just did it with a percent, a proportion up there. You could also do it with the percent proportion if you wanted to. You could say 33% times 90, or of 90. So 33 times 90 is 2970, divided by 100 is 29.7, or about 30%. So all of this math is the same thing. It's just written in different formats. And you can pick the one that you like, the one that makes the most sense to you. But at this point, I could say not 30%. That's 30 free throws that he would make out of 90. So any way you do it, that answer's 30. And I am going to check these because these are exercises. So let me turn back to page 73. Okay, 73, think about math. The first answer is 12, and the second answer is 30. So what did I miss on the first? Oh. In the first one, I'm sorry, I didn't finish it. I just found the probability of 1 flip. This is why I need to check. So this is one flip, but they wanted us to flip 48 times. And see, after all that emphasizing it, I still missed it. So 1/4 times 48. That's going to be 48 over 4, which is 12. It wasn't what's the probability. The question was how many times are you most likely to get 2 heads. So that would be the answer. And I'm glad I checked it. The second one's fine. We got that one right. But I would have missed the first one because I stopped too soon. Sorry. I'm very good at doing that. All right, I will see you back for page 74 in the textbook.